And welcome back for our part B on our 10.4 surface area net problems. Let's jump right into it. We have Khalil's going to cut apart a cardboard box. Cardboard box, we have a picture. To line the bottom of the hamster cage. How many square centimeters will he be able to cover using the box? So we're covering with square centimeters, not cubic centimeters. This is not a volume question. This is a surface area question. So similar to part A, we have a box. So we want to unfold the box into a net to find the surface area. So I've got the bottom of the box, which I'm going to draw in. Measurements 10 by 5. And again, I like to put the measurements on the edges. I can already go ahead and fill in the area of this box. It's 50. Then there's the front and back of the box. And the front and back of the box is 10 by 2. So we have a 2 and a 10 and a 2. That's 20. So this is also a 2, a 10, and a 2. So that's 20 square centimeters. I have the very top of the box, which has to be the same as the bottom. So this is 5, 5, 10. So this is another 50. And the left and the right. So we'll put that here. Has to lay down 5 by 2, which is 10. And over here, 5 by 2. Because this is 2, this is 5. And then we're again going to add all this together. So I have 50, I have two 50s, I have two 20s, and I have two 10s. When you do the rectangular prism, it's always 2 of each. So the front and the back are going to be the same. The top and the bottom are going to be the same. The left and right are going to be the same. It's always sets of 2. So we can add all these up. Well, that's a 0, 5, 10, 12, 14, 15, 16. So this is 160 square centimeters. Number 2 is an error analysis question. We have Kylie found the surface area of the rectangular prism below, but she seemed to have made a mistake. We're going to identify her mistake and then make the correction for what the surface area should be. I'm going to use the same kind of process that we used up in number 1 with this net to remind you this had two 50s, had two 20s, and it had two 10s. That should go on with this box because it's a rectangular prism. That's a box. So I have a 45 by 8, a 45 by 8. I have a 3 by 5 15, a 3 by 5 15. And then I have a 3 by 8 24. And then, oh no, that's not correct. So this 5 by 8 should have been a 3 by 8. So this is the top and then the bottom and then the front and then the back and then the left and then the right. So the mistake is in box 2. So the surface area should be two 40s, two 24s, and two 15s all added together. So 4, 8, 13, 18, 1, 5, 9, 11, 13, 14, 15. We should have 158 square inches instead of the 174. Onto the back. Now the back at this number 3 at a glance seems like it's going to be a little tricky. So let's do the reading. Square-based prism made of clay, so think Play-Doh, had dimensions 6 by 6 by 10. A pyramid was removed from the prism as shown below. So the prism has no top. So this is like a box with no top. Already I'm starting to think a box with no top only has 5 sides. It doesn't have the traditional 6 sides. It says specifically we have no top. And then what is the total surface area of the remaining clay if the slant height? So we do have something going on with the pyramid and the slant height of it being 10.5 units. Well, surface area is all the visible faces that you can see outside of the shape that you could actually touch without going to the middle of the shape. Since I've carved this pyramid out of the middle, that pyramid is actually going to be considered part of the surface area. Think about a house which has the traditional kind of pyramid roof, but you pick the roof up and you flip it upside down and put it inside the house. There's that indentation that's in the house. So I could unfold this into a net. It's going to be kind of a strange looking net. So it's got the square from the base, which is 6 by 6. And if I unfold, we have our rectangles from the box. And they're all 10 units tall. So we're going to label this is 10, 10. We're 10 all around. So we're going to fill in these areas. 6 by 6 is 36. 6 by 10 is 60. Each of these is 60. But then if I peel back the side of the box, again like a banana, I still have this triangle that will actually swing out and lay flat as well. So we do get triangles along the outside as well. And those triangles each have a slant height. So the height of the triangle is 10.5. So each triangle is the same. So we're now going to find the area of each of those triangles. Reminder, the formula for area of a triangle is base times height divided by 2. So the base of each of those triangles is 6. Put that in parentheses, times 10.5 over 2. 6 times 10.5 is 63. Over 2. And then 63 divided by 2 is 31.5. Each of these triangles is 31.5. So there are 4 triangles. There are 4 of the rectangles, so that's 4 by 6, 4 times 60. And then there's the 136. So we could even, just for formatting, put it like this. So 4 times 31.5 is 126. 4 times 60 is 240. And we can add all of this up for total surface area. 6, 6, 12, carry. 1, 3, 7, 10, carry. 1, 2, 3, 4. So we have 402 square units. And our last problem, talking about Finn wrapping a present in the shape of this composite solid. So this is, we would informally call this kind of a picture of a house. So this is actually going to make the same net picture as number 3, except instead of that pyramid being inverted into the box, it's actually going up the box. So this is still, if we look at the box at the bottom, it still only has 5 sides. This 6th side is not on the outside of the shape. It is not a face because it is contained on the interior of the box, so it doesn't count. When I unfold it into my net, we're going to have the rectangle at the bottom, which is 2 by 1. We've got the front and the back rectangle. So those are 2's. And then this is the front and back rectangle, 0.5. I've got the sides, the left and the right side. Which are 1 by 0.5, so 1 by 0.5, 0.5, 0.5, 1, 1, 0.5, 0.5. Then there's the 4 triangles, and we disregard the base of the pyramid, again, because it is sitting in the middle of the shape. It is not an outside face. So we have 4 triangles, so this is going to end with 4 triangles. And we are told that the slant height of each of the triangles is 1.5. So each one is 1.5. Now this is a little different because these triangles are not all the same size. So we're going to go through, we're going to find all of the areas. 2 times 0.5 is 1. 2 times 1 is 2. 2 times 0.5 is 1. 1 times 0.5 is 0.5. And again, 0.5. So those take care of my rectangles. Now to the triangles. Remember, base times height divided by 2. So we have 2 times 1.5 divided by 2. That's 3 divided by 2, or 1.5. So this is 1.5. This is 1.5, talking about the areas now, not the slant height of it. And then the other littler rectangles, it's 1. This is 1 by 1.5 divided by 2, which is 1.5 divided by 2, which is 0.75. So I'm going to write that off to the side just for space. And now we've got to bring all of that together. So we have 2 1s. So we have 2 1s. So 2 times 1. We can check that off. We have 1 2. We have 2 0.5s. We have 2 0.75s. And we have 2 1.5s. We should have 1, 2, 3, 4, 5, 6, 7, 8, 9 faces to this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, now we'll evaluate. 2 times 1 is 2. 1 times 2 is 2. 2 times 0.5 is 1. 2 times 0.75 is 1.5. And 2 times 1.5 is 3. And we'll add all this together. 0.5 comes down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our surface area. But let's make sure we've done the reading. The wrapping paper cost 15 cents per square foot. I automatically check. These are all feet. How much will it cost to wrap the present round to the nearest penny? So I'm going to take the surface area, the 9.5 square feet, and I'm going to multiply it by the cost per square foot. So we're going to do 9.5 times 1. Excuse me. We're going to do 9.5 times 0.15, pardon, and do a little multi-digit multiplication. 5 times 5 is 25. Carry. 5 times 9 is 45. Plus 2, 47. One placeholder. 1 times 5 is 5. 1 times 9 is 9. We will add all of this together. 5. 2. Carry. 4. 1. And I have 1, 2, 3 digits. So I have 1.425, but it does tell us to round to the nearest penny. So 1.425 rounded to the nearest penny is $1.43. I hope these you find these informative, you find these helpful for understanding these problems and mastering the skill of nets and surface area. Reminder, I am available for morning tutoring every Wednesday, Thursday, Friday in room 208 at 9 o'clock to 9:30. So hopefully you have a good rest of your weekend. Take care.